So let's do the same idea here. What I want to do is solve this for its general solution. Okay? I want to solve this for its general solution. Now, when I'm looking at this, excuse me, right up. When I'm looking at this right now, I've got sine times tangent squared is sine of x. So what do you think you're going to do?
You're going to divide the sine and then square root it, so you get that tangent equals the square root of 1.
Exactly. It looks a lot worse than what it sounds like. In this case here, this is, remember, treat this like you would variables. Worry about the trig function of it until the end. So if you divide both sides by sine, you wind up with tangent squared equals 1. And now you have to do what? Square root it. So you get tangent of x is going to equal, when I take the square root of 1, what do I get? No.
You get 1 square root.
Or
Plus or minus.
plus or minus. Remember, whenever you take a square root over an equal sign, you have to do the plus minus. Okay? Now, we do our inverse. We save the inverse for last, so x is going to equal the inverse tangent of plus or minus 1.
Wait, we're supposed to solve that.
Did you have to write that last step? Because I just went from like the square of x and then I
Well, you have to make sure you have plus minus though.
like on the test you showed till that.
As long as you have plus minus, I'm all right. Okay. Because you're right, like I said, there's going to be times where restrictions of some of the ways that you guys are solving equations, I know you guys can skip steps. I'm fine with that, as long as you as long as you get plus minus, I'm happy. So, what triangle is going to give you tangents of 1? The 45s again. So, which angle is it? The 45 or the 45 that gives you a tangent of 1? Exactly. So what is that in terms of radians?
Isn't that supposed to be a square root instead of plus or minus?
I'm sorry, what was that?
Isn't it supposed to be plus or minus square root of 1?
Well, when you take the square root of 1, you get plus or minus 1. Okay. So we're going to get 45 degrees as our answer here. Again, in terms of radians, what's 45 degrees? Pi over 4. So back to your circle. Pi over 4 is your reference. Oh, and look at it. You're going to get that same idea here where it's going to hit all 4 quadrants, isn't it? Because tangent's positive in the first and the third. It's also negative in the second and the fourth. So I'm going to have 4 possible solutions to this. We've got the pi over 4, 3 pi over 4, 5 pi over 4, and the 7 pi over 4. But again, in this instance, if I'm looking for the general solution, what do I have to tack onto this to make it work? Plus pi over 2. Okay. Pi again. What were you going to say, Lance?
That's
Oh, okay, yeah. So if this is a general solution problem, and you recognize that you're going to hit it in every pi over 2 interval, all you have to write is pi over 4 plus 2 pi, pi n over 2. That n just means the number of times you're moving it or not. That's all. 1, move it over once, move it to pi over 2, move it over twice, move it to pi. That drops you down diagonally. It's so on. Okay? Again, the trick here was to recognize that you had to divide by sine. Hopefully it wasn't so scared. Did anybody think that they were going to have to do what you were doing in 14.3? It's not that bad. We did those, so let's see here. Let's get to one that gets a little bit weirder. This is one we'll have to use a calculator for, and I'll show you why here in a second. When I set this one up, I have 4 times the tangent squared of x minus 1 is equal to 0. Again, we need to solve for x. So what are you going to do first, Mr. Hicks?
Plus.
Exactly.
Square root of it.
Does everybody agree? I'm going to add 1 and divide by 4.
Yes.
Is it okay if I just skip to right to that?
Yeah.
Tangent squared of x is 1/4.
Do we still need to write in the x? Or just like ignore it from
You can ignore it, it's not the end of the world. When I'm doing the equations, I like to put it in there. Bless you. When I'm doing all that simplifying stuff, I get it out of there because it's just too messy. So, now, does everybody agree we have to take the square root?
Yes.
Okay. What do you do when taking square root over an equal sign?
plus 1.
What's the square root of 1/4? Good, it's 1/2. So x is going to equal the inverse tangent of plus or minus 1/2. Does that fit in one of our triangles? No, it doesn't. So here's the big hint. If it doesn't fit in the triangle, what do you have to use? Your calculator. Okay. Now, here's what I want to look at. This was on the interval. This is going within 1 revolution. And notice your interval is in terms of what?
Pi.
So what should your calculator be in? Be in radians. Okay? That's the dead giveaway here. If your interval is given to you with pi in it, you want to be in radians on your calculator. If it's given you between 0 and 360, go ahead and leave it in degrees. Is that okay with that? So here's what I want to do. I am going to explain this to you in terms of degrees first. It's a little bit easier to understand what's going on before we go to radians. So for the time being, let's go back to degree land just to understand what's happening. Is everybody okay with that?
So switch it back.
Switch it to degrees for a second, and then we'll do all the exact same manipulations of the equation in radians in a minute. But I just wanted you guys to understand values. It's a little bit easier to get. All right, so in the calculator, get that thing. We get the inverse tangent of a half. Make sure I'm in degrees. Inverse tangent of a half. 26.57. Everybody okay with that? So that's telling me that the tangent has a reference angle 26.57. Now, when you're dealing with tangent, where else is it positive? Third quadrant. In terms of degrees, then, what would you have to do
You would add
to
180.
this value?
180.
Add 180. Very good. Yes, sir.
I thought it was plus or minus because of the square root.
It is. I'm just working on where else was it positive. Okay. So everybody's okay. This is the other solution then would just be adding 180 to that. All right. The negative value is over here then, correct? To get this reference, what are you doing?
180 minus
180 minus the x, so that's what? 133, no, 153. And then what would you do to that value to find it in the fourth quadrant? Add 180 again. That gives you your 4 possible solutions. Everybody okay with that? Now, if I switch this to radians, it's giving me what we would normally use as some fraction, but the calculator is spitting out crummy decimal. So switch your calculators to radians real quick. And we're going to do the exact same stuff. You can just hit enter again. And what this is doing, it's giving me that 26 and change degree angle in terms of radians. No, it already has pi in it.
Oh,
It's just already, it's basically doing the radians is already takes degree multiplied by pi divided by 180. If you did that long-handed with that decimal value, you would get this. So think about what that means. If this answer now is 0.46 in radians, we know it's first quadrant. 0.46 in radians. What would I do to that decimal value to get down here? What would I have to add to it? Pi. Very good. In order to get to the third quadrant, then I'd have 0.46 plus pi. And I can leave it like that. The calculator gave me first quadrant radian measurement in decimal form. Knowing how to move that value. What? People sit there. And knowing that tangent is also positive pi away from it, all I have to do to get the other value is just add pi. That's how I get the other angle. To get the angle here,
plus pi half, pi over 2.
not necessarily. It doesn't drop directly across like it would be at pi over 4. That's a very common mistake. Think about how you would get the reference angle. If, what is it? Excellent. What he's doing here to get this value here is you're starting at pi and you're subtracting the 0.46. Yes, sir?
So when you just read it as 1.6 plus pi, or do you
Leave it as plus pi. Okay. The other angle, so we know that we have an angle at, it's looking for on the interval of 2 pi. So our one angle is 0.46, comma, 0.46 plus pi. The other angle would be pi minus 0.46. And what would be the angle down here? How would I find that one?
2 pi.
Excellent. Everybody hear that? It would be 2 pi minus the... And that's how I get to my different angles. What I'm doing here is I'm still evaluating where the angle is going to occur. I'm still figuring out where it's going to drop into which quadrant. And then I play the games of where else is it positive, where else is it negative. Using the rules of reference angles, are you bouncing off your x-axis coming up? So I'm subtracting it from pi. Am I adding it to pi? Am I subtracting it from 2 pi? Things of that nature by moving it around, which you guys all know how to do, which you're really good at. It's just weird that instead of having it at pi over 6 and just moving pi over 6 around, you're moving it with 0.46 as a decimal equivalent instead. Okay? Again, all I'm doing is just leaving it in terms of pi, and it works out nice and clean. Okay? Not so bad. Usually the calculator one, it takes a minute or two to get what they're asking you to do because you have to visualize a little bit differently. So if you want, when you do your calculator problems, if you want to start with it like I did here, with in terms of degree to work with it, and then build off of it again later into radians, it's fine. It'll help you go as you start these things up. Do number 5. These are on intervals. We have not done an inverse yet. I'd like you to start with number 5, and I'll help you here in a second. I want to see how we start this. So we have 3 times secant squared of x minus 4 equal to 0. What do you think the first thing you're going to do is?
Well, since secant squared is technically sine, just add 4.
Add 4. Very good. So we're going to start with secant squared of x is going to equal 4 divided by 3. Everybody okay with that?
Yep.
Secant squared is the inverse of what?
Goes on.
So if I inverse both sides, What's the inverse of secant squared? Now if I inverse the left side, what's the inverse of 4/3? Now what do you do? Rooted. So the cosine of x is going to equal plus or minus root 3 over 2. Everybody see what we did there?
Wait, where did you get the square root?
This is.
How do you undo squaring?
Oh, you were squaring it. Wait,
Yeah.
how did you get your cosine?
What is the inverse of secant?
Oh, sorry.
Cosine. So if I inverse the right side of or the left side of the equation,
Oh, I didn't see
I
what you
inverse the other side.
Okay.
Yeah. What I'm doing here,
I was kind of working ahead. Could you just keep secant and then just do inverse of secant?
no, flip it this
Or, oh,
way.
wait a minute, there is.
Exactly. If you ever wind up with an inverse trig function, which you will, move everything around like you would normally until all you have on one side is the inverse trig function, whether it's just secant of x or secant squared of x or cosecant or whatever. At that point is when you do the inverses and you just inverse both sides. You're keeping your equations balanced, you're just flipping the fractions. And then from there, it's relatively straightforward.
It's a 30.
Which one is it?
Is it a 36 or 90?
It's a 30, 60, 90 triangle. So I'm looking at cosine being root 3 over 2. So let's see here. 60, 30, so that's root 3, 1, and 2. Which angle gives you the cosine of root 3 over 2?
30.
The 30. So the 30-degree angle, which is known as pi over 6, very good. So in my triangle, or my unit circle, pi over 6 is here. Where else is cosine? Oh, wait a second. Take a look. It's plus minus, isn't it?
Yeah.
So what am I looking for? I'm looking for every single quadrant with a reference angle of pi over 6. Pi over 6, pi over 6 down, and pi over 6 down. I don't have to worry about tacking on 2 pi n's to anything because the problem itself told me that it's within 1 revolution. So my answers would be pi over 6, 5 pi over 6, 7 pi over 6, and?
Yes. Now, without the boundary from the interval,
Yes.
then you can do the plus pi n over 2 or plus 2 pi.
Oh, you would be, with this one, you'd wind up being a plus 2 pi n for all 4 of them, because there's not a common interval between each one of them.
But then if you were to go, then it will, since there's a boundary of 2 pi, then you'd be exceeding 2 pi.
Right. But if there wasn't,
Yeah.
you'd have to tack 2 pi n to each of those 4 values. The only time that one works where you're just doing that pi over 2 value is when it creates the square, when you're working with tangent.
Oh.
That's the only time that one's going to work out like that, because it's the exact same interval between all 4 values.
Can you
Whereas
do 2 pi n for that one too?
you can, but it's more specific just to tack on that way.
Okay.
Inverse, not so bad, is it? All right. Let me give you a couple of these to try. I want to pass back to you guys what you did yesterday real quick. Kevin. It's making you stop within 1 revolution. You're just looking for all the angles within 1 revolution. If it says general, you're just tacking on how long it didn't give you an accurate answer. Okay. So it's the same page as it was yesterday. What was that, 859?
Yeah. Same.
So there's 8 of them. 4 of them are general, 4 of them are within 1 ringy-dingy, 1 revolution. Okay. We'll try that out. Okay? Remember, if you don't get something on the circle, you have to use your calculator. Bless you.